Code subject BDA 24303. Subject name Differential Equation. Semester 1, section 2020/2021. Report title Application of First Order and Second Order Linear Differential Equation. Group members Ahmad Najmuddin bin Zamri, CD190T27, Muhammad Amza bin Afandi, CD190T09, Muhammad Azri Shah bin Syahrul Rizam, CD190T03, Muhammad Aiman bin Abdul Manah, CD1900144, Nur Rashidah binti Lokman, CD1900050, Nur Faisal binti Muhammad Riki, CD190T3.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Abdul Manah. Today, okay, now I want to present about first order differential equation. Okay, for introduction, first ODE has wide application in various engineering and science discipline. In general, modeling operation of a physical quantity such as temperature, pressure, displacement, velocity, stress, strain, current, voltage, concentration of pollutant with change of time or location, or both of result in differential equation. In fact, many engineering subjects such as mechanical vibration or structure dynamic, heat transfer, or theory of electrical circuit and are found on the theory of differential equation. Okay, second we move the definition. Definition is the objective is the differential equation involving ordinary derivative of one or more dependent variable with respect to a single dependent variable and which has only order derivative is called first order differential solution. The topic for case study, our group is kinematic analysis of rigid body dynamics. For our case, in our case, we use separable method to solve our case because this method is suitable to solve case study. In our case study, we have 4 steps for solving our case study, which is method of identification. That's dy over dx is equal f xy. Second is solution of separable equation by integrating in both side the of equation. Third is solving dynamic problem. If you know Newton's second law. And fourth is the type of unknown and given information point to the best method to use. From our sample question, our group choose about free fall in dynamic analysis. Okay, from our sample question, we can conclude that the first The first order differential equation in free fall of a solid are useful in mathematics physics. For instance, in analysis problem involving free fall of solution problem which is required to use of Newton's second law. Newton's second law are the most approximate method in solving Newton's second law is variable of separable. Uh, from from the separable method, we can obtain the first deriving the mathematic expression and solve the for the solution. The force acting on the falling solid should be in equilibrium at time, and we obtain by evaluate the velocity in equation of time. Okay, in our to to more detail to more details about our case study. Our case study is about when about pursuit. Uh, Participant is joined the parachute and she jump from the helicopter and free fall with parachute. Okay, that's all from me. Thank you.
Hello, Assalamualaikum. My name is Azri. So today I will present about second order linear differential equation. So, introduction. Vibration is a continuous cyclic motion of a structure or a component. Generally, engineers try to avoid vibration because vibration have a number of unpleasant effects. The first unpleasant effect is cyclic motion implies cyclic force. Secondly, even modest level of vibration can cause extreme discomfort. Thirdly, vibration generally lead to a loss of precision in control machinery. Next, objective. The first objective is to recognize and solve constant coefficient linear second order differential equation. Secondly, to identify research problem where differential equation can be used to model the system. Thirdly, solve a second order differential equation representing damper and simple harmonic motion. For the solution method, this is a second order linear differential equation. Its auxiliary equation is mr squared plus k equal to 0 with a root r equal to plus minus wi, where w equal to square root k over m. Thus, general solution is xt equal to c1 cos wt plus c2 sin wt equal to xt equal to a cos wt plus alpha, where frequency equal to w equal to square root k over m, amplitude a equal to square root c2 over 1 plus c2 over 2, and the phase angle equal to cos equal to c1 over a. For the general solution, we encounter linear differential equation of second order in many engineering problems. In this section, our attention is focused on obtaining a method for finding a solution of a homogeneous linear equation of second order with constant coefficient, namely the equation a d square y equal over dx plus d dy per dx plus cy equal to 0, where a, b, and c are constant. Next, for the boundary initial condition, the first thing needs to be done is describe what the boundary value issue means, BVP for short. With initial value problem, the differential equation define the value of the solution and an approximate number of derivation at the same point collectivity coordination condition. For example, for a second order differential equation, the initial condition as are follow: y bracket t 0 equal to y 0 and y prime bracket t 0 equal to y prime 0. Next, the particular solution. In this topic, our discussion focus on linear ordinary differential equation of second order. The discussion begins with the classification of the equation and is followed by the concept of linear dependence and independence. We further discuss the solution of linear homogeneous and non-homogeneous differential equation in this form of an exponent function, which is also the characteristic of the solution of linear differential equation of first order. Let's begin with the following linear homogeneous equation of first order: d dy per dx plus py equal to 0, or dy per dx plus py equal to 0, where p equal to c over b, or dy equal to dy over dx equal to negative py. The only function that can be satisfy the equation is exponent function e equal to px that yield a constant multiple of itself with differential, or more precisely, the complete solution of equation is y equal to ae negative px. It is thus nature to try y equal to exponent mx as a solution. Therefore, y equal to exponent mx satisfies if only and only if am square equal exponent mx plus bme mx plus ce mx equal to 0, or am square plus bm plus c exponent mx equal to 0. From the above equation, it apparent the characteristic equation can be obtained from the differential equation by replacing d square y over dx equal to m square, dy equal to dx equal to m1, and y equal to m0. That's all from me, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. My name Norashida binti Luqman. My metric number CD190050. I want to present about conclusion in our project. In this project, we have subtopic, two subtopic. First topic is about first ODE and the second topic is about second ODE. Firstly, I want to explain about first ODE. Application of first ODE is kinetic analysis of rigid body dynamic. The method we use is Newton's second law, and the formula is total F equal mass multiply acceleration. Also, in first ODE, we have two cases. Case 1 about free fall of a solid. The force acting of the falling solid should be equilibrium at the time by using coefficient of force along positive in x-axis bin. For case 2 is about draw up of solid with velocity. As in the case of the fail for the force acting on the up moving solid should be a equilibrium at the time. Next, I want to explain the second ODE. Application of second ODE is print variation in the The method we use is no homogeneous linear equation. Also, they use the Newton's second law and Hawking law. The most appropriate method is solving Newton's second law is separable. That's all for conclusion. Thank you.
Thank you, my friend Rashida. Hi, my name is Nofarisa. I will be continuing this presenting by present my part, and my part is minute meeting. First minute meeting is on 27 November 2020. Conduct first meeting with all members and brainstorm some idea based on topic given. Explaining the objective of first ODE's topic, group members choose their part while discuss the content that must have in this report and discuss existing engineering application for this first ODE topic. Share our research about first ODE and dynamic. Second meeting is on 9 December 2020. Explaining the objective of second ODE's topic, member group choose their part while discuss the content that must have in this report and discuss existing engineering application for the second ODE's topic. Share our research about second ODE and vibrating spring. The third meeting is on 20 December 2020. All members send their part and we make a discuss and correction in our project. We exchange information and complete our part. And the last one is on 29 December 2020. All members successfully send their part to one of the members to compile all the part into a project report. We do the last checking, then we submit to the lecturer. That's all. Thank you. After this will be continued by Ahmad Najimuddin.
Okay, hi, I'm Ahmad Najmuddin. Now I will talk about group member contribution. Okay, firstly, for Ahmad Najmuddin bin Zamri, he makes for part A background of engineering application, and the second one is important of problem and solution. Okay, for part B, he makes the different case for root and different value of spring and damper. Okay, for the next person, Muhammad Hamzah bin Nur Afandi. Okay, for part A, he makes a background of engineering application and importance of problem and solution. Okay, for part B, he makes depends and independent variables, and the second one is the method of solution. Okay, for Muhammad Azri Shah bin Shahrul Nizam. Okay, for part A, he makes a particle solution and discussion of the result. Okay, for part B, particle solution and discussion of result also. Okay, the next person, Muhammad Aiman bin Abdul Manaf. Okay, for part A, he makes a variable involves, and the second one is boundary and initial condition. For part B, he takes background of engineering application, and the second one is condition of non-homogeneous. Okay, for Novalisa binti Lukman, for part A, she makes derivation of equation and the method of solution. Okay, for part B, she takes boundary and initial condition and also conclusion. Okay, for the last person is Novalisa binti Muhammad Rizki. Okay, for part A, she takes a sample calculation. Okay, for the second one is edit and compiling. Okay, for part B, she also take a simple calculation and edit and compiling. And there are some more reference and minute meeting. Okay, that's all. Thank you.